Okay, so today we're going to talk about how to find area and perimeter of figures that are in the coordinate plane. Um, so here you're going to talk about how to find the area of a rectangle, how to find the area of a triangle, and how to find the perimeter of a polygon. And we've already discussed in some of the classes that perimeter means to add up all of the outside pieces, and area means to find the space on the inside, and there's normally formulas for that. So let's try this first one together. It says given points A, B, C, and D, find the perimeter. So I want to find the rim of this quadrilateral. So I'm going to go apply all the points. So I get 1, 0, which is A. And then we get -1 and 2, which is B. And then we get 2, 5, which is C. So 2, 1, 2, 3, 4, 5. And then we get 4, 3, which is D. 1, 2, 3, 4, 1, 2, 3. So this was C and this was D. And then here we want to find a perimeter. Perimeter means to add up all the sides. So I'm just going to go ahead and connect these dots here. Alright, so in order for me to find a perimeter, I need to add this side, this side, this side, plus this side. So what I need to go and do is find the length of these sides. Now there's two things you can use. You can use the distance formula to find the length of AB, BC, CD, and DA, or you can use Pythagoras Theorem. I'm going to use Pythagoras Theorem because I just think it's the simpler one to use. So the distance for line segment BA, if I draw a right triangle here, it's going to be 2 and 2. So if I use Pythagoras Theorem, I get A squared plus B squared equals C squared. So there, I'm going to do 2 squared plus 2 squared equals C squared. And I'm going to keep the math going there. 4 plus 4 is C squared. So 8 equals C squared. Take the square root. C equals the square root of 8. And you can leave it as the square root of 8. Now I'm going to go ahead and do the same thing for line segment. I want to find the distance for line segment AD. Alright, so you can either use the distance formula or you can use Pythagoras Theorem, whichever way you want to do it. We get 3 and 3 here, so to find the distance of that, then I'm going to do A squared plus B squared equals C squared. So we get 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. 18 equals C squared. Square root of 18 equals C. Alright, so I found line segment BA. I found line segment AD. I found this to be the square root of 18. And I found this to be the square root of 8. Now I'm going to go and do the same for CD and BC. So if I draw my line for CD, I go here. So 2 and 2. So I'm going to go use my Pythagoras Theorem. And if you notice, we got lucky that this appears to be a rectangle. I have 2 and 2 here, and the distance here is 2 and 2, so I don't really have to redo any math. I can just say the distance of, I'm going to change this color because it might look bad on your end. Distance here for CD, and let me make sure that's CD. Yep, the distance for CD would be equal to the square root of 8 because the right triangle looks exactly the same as the other side. It doesn't work out like this all the time. We just got lucky with this problem that it did work that way. Alright, so now I'm going to do the same thing for BC. I'm going to draw that right triangle. So 3 and 3. Well, I got lucky. This is appearing to be a rectangle. It could be a parallelogram, but these two sides here is the same as this side, so I do not need to redo any math. So here I get the distance of BC is equal to the square root of 18. So here, square root of 18 is what we get here. And now I haven't answered the question because perimeter means to add all the sides. So you can go and add all these together. Square root of 8 plus square root of 8 plus square root of 18 plus square root of 18. And we're going to get what the perimeter equals. And I'm using P for perimeter. I think that's a standard notation for perimeter. So here, I'm going to turn it on. Square root of 8 plus square root of 8 plus square root of 18 plus square root of 18 equals 14.14. Alright, so we get 14.14, and we don't know the units here, so we're just going to say units, and perimeter is a linear unit. Alright, so there you go with the perimeter for that one. Now let's go here and let's find the area of these given 3 points. So I'm going to go plot them 0, -2. I'm just going to call it A. And then I'm going to go to 0 and 2, 1, 2, and call this B. And the next point was 4, 0, 1, 2, 3, 4. And this here is C. Well, this is a triangle. All right. We have 3 points, so we have some type of triangle here. So I'm going to connect these dots. Alright, so I connected the dots. So to find the area of a triangle, then you do area equals 1/2 the base times the height. And you do not have to memorize this formula. This formula is on your formula sheet. So just know that this is a triangle, and then go find that formula. There's another way it can be written too. You can do base times height divided by 2. That's another way. So either way, both formulas are correct. So we need to figure out a couple of things. We need to find out what the base of this triangle is and what the height of this triangle would be. Okay, so this is the traditional way to find the area of a triangle. Now, the issue with this problem is it is very hard for us to identify the height of this triangle and the base of this triangle. So we're not going to use that method to actually find the area of this triangle because it's very hard for us to identify the height and the base. So we're going to use another method, and it's called the box method. So here's what we're going to do. We're going to draw a box around this triangle. Let me just use my pencil instead. Hold on, babies. I'm going to make it a dotted box so you can see. So we're going to draw a dotted box around this triangle. And now what you notice is that I can easily find the area of this dotted box around the triangle. So what I'm going to do is the area of a rectangle. So we have the area of a rectangle is length times width, or you might have seen base times height. Both of them are the same. So to get the area of the rectangle, we're going to go 1, 2, 3, 4. That's 4 for the width, and then or the length, it doesn't matter which one you call it. And then 1, 2, 3, 4, 5, 6. 6 going across this way. So to get the area of that, you're going to do 6 times 4, which is 24. So we know the area of the whole thing is 24. Now, in order to find the area of the blue one, then we need to find the area of these little pieces of the rectangle. Okay, so we're going to find the area of each one of those. So I'm going to just highlight those so you can see. So I'm going to find the area of the yellow one, and I'm going to call that triangle 1. I'm going to find the area of this one, triangle 2. I'm going to find the area of this one, triangle 3. Alright, so the area of triangle 1, would be 1/2 base times height. So what I'm going to do is do 1/2 the base times the height for that one. So the base of that would be 1, 1, and 2 of triangle 1. And I'm going to go and erase this piece here so you can see. So if I call this triangle 1, which is right here, let's go ahead and highlight it in yellow so I can keep it consistent. This is triangle 1. And the height of it is 4, and the base here is 2. So I'm going to say 1/2 times 2 times 4. And I get 4 times 2 times 1 is 8. Divided by 2 is 4. So the area of triangle 1 is 4. So this takes up 4, and that's units squared. And you can write units squared because area is a square unit. And now if we do triangle 2, we're going to use the same formula, 1/2 base times height. I'm going to do that one in black. So the height here is 2, or you can call it the base. And this side here is 1, 2, 3, 4. This side is 4. So what you're going to do, the area of that triangle 2 would be equal to 1 over 2 times 4 divided by 2. And then that area would be 8 divided by 2 is 4. And that's 4 units squared. Now I'm going to go to triangle 3. Let's use the highlighter. I'm going to make this triangle 2 orange so you can see. And then I'm going to make this triangle 3 blue. Alright. So here I'm going to go and find those dimensions. This is 1, 2, 3, 4, 5, 6. 6 here and 2 on this side. So the area of triangle 3 equals the same 1/2 base times height. So area of triangle 3 equals 1 times 6 times 2 divided by 2. So you get the area of triangle 3 is 12 divided by 2, which is 6 units squared. Alright, so I got that knocked out. So I know what all my areas are. So to get the blue, the area inside of this triangle, which I'm going to color as green, to get this green part, then what I'm going to do is take the area of the whole triangle, not the whole triangle, the whole rectangle, that purple rectangle. So I'm going to say 24 minus the areas of each one of those pieces. So I'm going to subtract out this area, and this area. So I'm going to go down here and say 4 minus 4 minus 6. 24 minus 4 is 20. Minus another 4 is 16. Minus another 4 is 10. So the area of that triangle, so the area of the big triangle is going to be 10 units squared. And that's the area of the big triangle, of that blue triangle sitting in the middle. And that's how you solve these when they're on the coordinate plane. It's not easy to find the base and the height of these when they're on the coordinate plane. So you have to first do the box method, find the area of the rectangle around it, and then find the area of the 3 or 4 or 5 rectangles that are around the figure, and then subtract those those triangles out of the big rectangle, and then you get the answer. So it takes some work, but go ahead and work with it. It's just putting those formulas together and subtracting things out. Okay, I will see you guys on the next go around. Go ahead and try these problems. Please try them out so you can come to class tomorrow, and all we have to do is talk about it. Okay, bye guys.